In this video, we're going to look at one of the most famous problems, possibly the famous problem in graph theory, and that is the traveling salesman problem. Now, remember from our previous video, we defined what a Hamiltonian circuit and Hamiltonian path are, and that is a circuit or path that visits every vertex without repeat. The traveling salesman problem, though, is really one that focuses on a circuit. All right, I'm just going to highlight that here. All right, we're not really going to consider the paths. And the reason would be that the idea of a traveling salesman is that a traveling salesman might start at a particular city, maybe your home base where you live, and travel to a variety of cities on a sales tour, and then eventually come back home because you always want to come home after your tour is over. So here is the definition for it. A mathematical problem, the traveling salesman problem, is a mathematical problem in which one tries to find the shortest route. Now, I will say that also sometimes shortest could be defined in miles, right? Like a distance, but it could also be defined in time. So I don't know which one we're talking about, but the answer is that we talk about both. And interestingly enough, you might know that time is money. So we can also consider the cheapest route. So shortest, as far as time, or cheapest, that passes through each set of points. So it's Hamilton, right? Once and only once. That's a Hamilton. We will use weighted graphs to decide this. A weighted graph is a graph that either displays the mileage or the time or the money that it costs to travel that route. So let's go to an example here local to our college. All right. So here we have a Google map that I took a snapshot of. We have the cities of Lemoore. We've looked at this problem before. We have a close community of Armona, close community of Layton, and Riverdale. Now, you can drive from any one of these to another one. Let's say that my home base was here at the college in Lemoore. I could drive to Armona. I could drive to Layton. I know that's not an exact path, right? I'm not following the roads, but there is a path. I could drive to Riverdale. But I could also go from Armona to Layton and Armona to Riverdale, or I could go from Riverdale to Layton. In other words, there's ways to get from any city to any city. And in a previous video, I highlighted those and looked at the mileage. So let's just take a look at that. Here's an abstraction of this map, all right? And we will consider a weighted graph. I calculated these in a previous video, but the distance from Riverdale to Layton is 9.7 miles. And the distance from Layton to Armona is 9.2. Lemoore to Armona is 4.9. The distance from Lemoore to Riverdale is 12.9 miles. And then we have these paths through the middle. Lemoore to Layton is 14. And then from Riverdale to Armona is 16.3. So the game would be played like this. If you're a traveling salesman, right? Traveling salesman, then what you're going to do is start at your home base, Lemoore, right? And you're going to try to go to every one of the other communities, and then come back home in the cheapest or fastest way. In this case, we're going to say the shortest way because these are actually mileage charts. So one way to attack it is just think like, well, I could go around the outside. Right? Maybe that's the fastest. And that would be a total distance of 4.9 plus 9.2 plus 9.7 plus 12.9. That's a way to do it. That doesn't mean that that's the answer, though. I mean, it is possible that I could go through the middle and maybe find a shorter one, and maybe not. So maybe I could do something like I could start at Lemoore, and I didn't fully erase that, so let me just erase that a little bit better. I could start at Lemoore, maybe go to Layton directly, and then go to Riverdale after that, and then go over down to Armona and then back to Lemoore. That's also a Hamiltonian circuit, right? I've covered everything. However, I have different mileage. In that case, I had 14 plus 9.7 plus 16.3 plus 4.9. Now, you probably can just tell by looking that the first one seems to be better than the second one, right? I have two of the numbers are exactly the same, but then the other numbers don't compare. Well, they compare, but the first two are definitely smaller than the second two. So this seems to probably be the best route. Now, are there other possible circuits? Well, there might be. We didn't look at every single possible one, but the idea of the traveling salesman problem is to find the shortest one. Now, it seems fairly manageable with something like 4 communities and just a few distances. But if we make this a little more complex, you can see that we need some better algorithms to figure this out. So what if you're actually a salesman or a salesperson that has to go to a lot of different communities? Maybe you live in a major community. Let's say your base here maybe is in Los Angeles. Okay, and then these other cities on the map are cities that you need to, let's just say for the sake of this problem, you need to drive to. Okay. They're Las Vegas, Phoenix, Denver, Salt Lake City, Boise, Idaho, Seattle, and San Francisco. Well, what would be the best route, the cheapest route, the fastest route, or the shortest route is what we're going to look at to go from LA back to every city and back home? Well, it might be fairly obvious that you don't want to just go from LA to Seattle, that you might want to go, from LA to San Francisco to Seattle, and then maybe to Boise, Salt Lake, Denver, maybe Phoenix, Las Vegas, and Los Angeles. That's like one possibility, but maybe not. Maybe actually it would be a little bit better to go from LA first to Phoenix, and then to Las Vegas, and then to Denver, Salt Lake. In other words, notice those are slightly different routes, right? And there's lots of routes that we could do. We could actually do. We don't have to go to Las Vegas or San Francisco first. We could definitely go across, but that looks like it's going to be longer. Like this is probably a really bad path that I drew here, right? But that actually is a Hamiltonian circuit. I went to every place and started and stopped at the same spot. Well, what happens is mathematically, here are all the possible connections. Wow, that's every city connected to every city. And you could travel down those edges and travel to every city and make a Hamiltonian circuit. And the question would be, which one is the cheapest? So one way to do that is to take a look at a mileage chart. Now, these are miles I got. These are driving miles. Driving miles I got from Google Maps, and I just recorded them here. And you're going to see it's a little overwhelming. So what we're going to be studying with the traveling salesman problem is ways, algorithms, techniques we can use so that we can find the shortest route. Now, the interesting thing about the traveling salesman problem, this is what I'll close with, it has never been solved. In other words, we don't have any real way to solve the traveling salesman problem efficiently. I should say there is a solution, and that is just check every possible Hamiltonian circuit that there is. The issue is that as you add more and more and more places, more vertices, then the problem becomes overwhelming to try every possible route. Even computers will struggle if you have something like 50 cities or 50 spots. So when I say never solved efficiently. Like we haven't yet found a very good technique for finding the shortest route and doing it in an efficient way. Okay, this has been Traveling Salesman Problems.